Hello everyone. In this video, let's discuss how to delete the element in the beginning of the linked list. Okay, let's take a linked list. Here I need to delete this particular node. After deleting this particular node, this node should be the first node of the linked list. Let's take a temporary pointer variable and point to the first node. After pointing to the first node, I'll take the second node address. How come I can take the second node address? So the pointer variable is pointing to the first node. So this pointing to the first node's data and this point to the second node's address. So I'll take the second node address, I'll store it in the head. The reason why we are storing the second node address in the head in the sense, if I delete the first node, the second node should become the first node. Head should always point to the first node address. That is why we are taking the second node address and we are storing it in the head. After this, delete this particular node by using free function or delete. Now we have deleted the first node of the linked list, which means we have deleted the element in the beginning of the linked list. Let's try to implement this concept with the help of a program as usual. Now let's give a message saying that cout linked list before deletion. So we should know the difference between before deletion and after deletion, right? So I'll give a message saying that linked list before deletion. I'll print the linked list. Okay. Then I'll give a message saying that linked list after deletion. Okay. And then I'll call a function. So here I'm going to delete the element at the beginning of the linked list. So delete in the beginning. I have to pass the address of it. Remember this very carefully. I have to pass the address of it. So I have called a function. So let's define the function now. Void delete in the beginning. So here what I have passed, address of it has been passed. Struct node star head. I'll give head underscore reference for our understanding. We have to implement the logic. Here I have passed the address of head. So here what should I store? I need to store the address of head. The address of head is 1000. That 1000 has to be stored in headref. Okay. This headref is a double pointer. I have passed the address of it, not the value of it. I have passed the address of it. Address of it is 1000. That has to be stored in headref, which is a double pointer. Now what I'm going to do is I'm going to take one temporary pointer variable. Struct node star temp is equal to star headref. So what I have done here, I have taken one temporary pointer variable. Fine. In this pointer variable, what am I storing? I'm storing star headref. Headref is a double pointer. Here I'm taking single pointer. So we have to dereference once. So headref is here. So dereference once 1000. So I'll go to the memory location 1000. What do I have? 2004. So I'll take this 2004. I'll store it in the temp. Now what I have to do? I have to change the value of head. So head underscore reference is equal to head underscore reference of next, or I can say, in short, I can say temp of next. It is very easy for us to understand. In the head, what am I going to store is temp of next. Temp is pointing to the first node. The first node address is 2004. Temp is pointing to the first node. So in this particular node, temp of data will point to 10. Temp of next will point to 3000. So this 3000 is nothing but second node address. So what am I doing is, I'm taking temp of next. So temp of next is 3000. I'm taking this 3000. Where am I going to store? Star head reference. So head reference is a double pointer. If it is single star head reference, I have to dereference only once. So 1000. So in the memory location 1000, what I have? 2004. Here I'll store the temp of next. Temp of next is 3000. I'll take this 3000. I'll store it in this particular place. After this, what I have done? I have to delete the first node. So free of temp, because temp is pointing to the first node, right? So address of temp is 2004. This is the 2004. So I am deleting this free of temp. So this will be deleted. Now head is pointing to the first node, which is 3000. Data path 20. Next node is 3012. Data path 30. Next is null, which means that we are in the end of the linked list. So this particular node has been deleted. This becomes the first node and this becomes the second node. Let's print and check once whether the element has been deleted or not. So I'll give print underscore list. I'll pass the head. Let's run the code now. I have given the size of the linked list to be 5. I have 5 elements, 10, 20, 30, 40 and 50. Here I have inserted the element at the end of the linked list. So let's run. So linked list, okay, I should give a new line after printing. That's why cout and I'll run once again. Yeah, linked list before deletion, I have 5 elements in the linked list, 10, 20, 30 and 40. Linked list after deletion, I have deleted the first element of the linked list, which is beginning of the linked list. After deleting 10, the linked list contains 4 elements, 20, 30, 40 and 50. That's all.